Welcome to Engineer's Tech Book. Today we're mastering the humble tape measure, a tool you've seen 100 times, but maybe not truly understood. From fractions to standout tricks, we'll explore why precision matters. Whether you're fine-tuning an HVAC setup or fitting engine components, this guide ensures your measurements are no longer guesswork, they're engineered. Let's start with the anatomy. That wiggly hook. It's designed to move slightly to ensure inside and outside measurements stay accurate. The standout length? That determines how far you can measure unsupported. And the lock? A must for marking with confidence. Next, reading the measurements. Imperial and metric lines, fractional breakdowns, and the smart burning an inch technique. It's all about understanding how these marks translate to your work. We'll also look at tight space strategies and finish with pro tips, like body positioning and marking accuracy, that set your work apart. Stick around till the end for Engineer's Tech Book bonus tips and design insights.
Disclaimer: this video is intended for informational purposes only. While care has been taken to ensure accuracy, the methods and measurements shown may vary depending on equipment, environment, and user handling. Always follow the manufacturer's guidelines for your specific measuring tape. The presenter assumes no responsibility for misuse or misinterpretation of the content. A measuring tape, also known as a tape measure, is a flexible ruler used to measure length or distance. It typically features a long strip of metal, cloth, plastic, or fiberglass, marked with linear measurement units such as inches or centimeters. Metal versions often retract into a compact housing, making them ideal for construction and engineering tasks, while cloth and fiberglass tapes are commonly used in tailoring and more delicate applications. There are two basic types of cased measuring tapes: spring return tape and manual return tape measure. While spring return tape measures are compact and self-retracting, while manual return measuring tape are designed for longer distances and often require manual winding, often via hand crank. The tape measure has also entered into the digital age with the digital tape measure. Some incorporate a digital screen to give measurement readouts in multiple formats. There are also other styles of tape measures that have incorporated lasers and ultrasonic technology to measure the distance of an object with fairly reliable accuracy. Tape measures often have black and red measurements on a yellow background, as this is the optimal color combination for readability. The length of measuring tape. The most common tape measures are 3 meters or 10 feet, 5 meters or 16 feet, 10 meters or 33 feet, and 100 feet in length for roll type. 3.5 meters or 12-foot tape measure is the handiest one for consumers. Basic usage and purpose to measure length and distance. Tape measures used in tailoring are called sewing tape. Originally made from flexible cloth or plastic, fiberglass is now the preferred material due to its resistance from stretching or tearing. Sewing tape is mainly used for the measuring of the subject's waistline. Measuring tapes designed for carpentry or construction often use a curved metallic ribbon that can remain stiff and straight when extended, but can also retract into a coil for convenient storage. This type of tape measure will have a hook on the end to aid measuring. The hook is connected to the tape with loose rivets through oval holes and can move a distance equal to its thickness to provide both inside and outside measurements that are accurate. Self-marking tape measures allows the user to have a graphite tip, allowing for accurate markings. Surveying requires the measuring of large distances and require an increased need for accuracy. Due to this, measuring tapes used for surveying may be made out of invar because of its low rate of thermal expansion. Tape measures are commonly used in construction, architecture, building, home projects, crafts, and woodworking. They usually come in lengths from 6 feet to 35 feet long These are the brands of measuring tape. To use a measuring tape, follow these steps. 1. Place the tape's hook at the end of the object you're measuring. 2. Stretch the tape across your object, keeping it as straight as possible. 3. Read the nearest mark to find the measurement. 4. Use the lock switch to keep the tape at the same length. 5. For outside measurements, hook the tape onto the edge of the object. For inside measurements, hook it from the opposite side and pull towards you. 6. When you are done measuring, you can retract the tape back into the case by pressing a button or releasing a lock. Some tape measure has magnetic hook that can stick to metal surfaces for convenience. Zero 1 indicates 12 inches or 1 foot. These 16 inches marking indicates the studs, the vertical boards that hold up a wall behind the drywall in a house, are normally 16 inches apart. The highlight on each 16 inches, 16, 32, 48, etc. on a tape make it easier to read for the user. The small black diamonds or triangles on the top scale of the measuring tape starting at 19.2 inches or 19.3/16 are for truss layouts for 8-foot sheet goods. They are also known as the black truss markings. Most tapes sold in the United States are inches and feet based. Some tapes have additional marks in the shape of small black diamonds appearing every 19.2 inches, 488 millimeters, used to mark out equal spacing for joists, 5 joists or trusses per U.S. standard 8-foot, 2,438 millimeter length of building material. Many U.S. tapes also have special markings every 16 inches, 406 millimeters, which is a U.S. standard interval for studs in construction. 3 spaces of 16 inches make exactly 4 feet, 1,219 millimeters, which is the U.S. commercial width of a sheet of plywood, gyprock, or particle board. Units used for measuring tape. International Standard SI or metric units. Measuring tape with imperial or inches units. Measuring tape using combination of metric and imperial units. Measuring tape using metric units. International Standard SI or metric units. Big numbers indicate centimeter unit example 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, 5 centimeters, and etc. Small line indicates 1 millimeter example from 3 centimeters to 4 centimeters. It has 10 millimeters. Because there are 10 small lines, 1 centimeter equals 10 millimeters. Measuring tape with imperial or inches units. So, as you can see the example, there are big numbers shown. It indicates inches, and every single line indicates 1/16 inch. That in 1 inch, there are 16 of 1/16. Therefore, if you can see it at the top zoom picture, you can determine the exact division of every single line of the tape. Big numbers equal to full inches. Example 1, 2, 3, and etc. Medium lines equal to fractions like 1/2, 1/4, and 3/4 of an inch. Smallest lines equal to 16ths, 1/16. There are 16 of these per inch, each representing 0.0625 inches. Measuring tape using combination of metric and imperial units.
This is just the combination of both metric and imperial measuring tape. These are the example of measuring tape having both metric and inches measurements. From the top of it is imperial or inches and at the bottom is metric or millimeter readouts. Big solid numbers on top gives you the inches readouts and at the bottom it will give you the centimeters or millimeter reading. Top edge, imperial units, inches, often marked with bold solid numbers for easier reading. Bottom edge, metric units, millimeters or centimeters, usually shown in finer gradations.
Thank you. Hope you learned in this video.